So you want to make an app, but wait, you have problem to choose the right database for your app. Choosing the right database is very important because if your app data size and data traffic increase in the future, it can cause a problem. Things might be complicated. Well, you may ask, which database should I choose? First of all, I need to say that I can't say this database is best choice, just use it. We must choose the database according to our app needs. We should find answers for some questions such as which kind of data type we are gonna use in our app. Is it integer or a string or a JSON file, etc.? Are you gonna use complex query in your app? Will your app need more storage space to store more data in the future? Today, we are gonna learn the Sql and Nosql databases in detail. So, after this video, you are gonna have some ideas about these databases to choose one for your app. Alright, here we go. Guys, we are gonna stand on 3 factors while choosing a database for your app. These are atomicity, scaling, speed. So what is atomicity? Atomicity provides consistency in database. It guarantees that certain processes will work together. For example, let's say we have a person called Adam. And we have another one, let's say Isaac. Now, suppose Adam has a $5, okay? And he wants to send this $5 to the Isaac. What will happen in this scenario? First, $5 must be deducted from Adam, right? And in second process, that $5 should be added into Isaac's account, right? So let's suppose the transaction failed after the first process finished and before the second process started. So what is expected in this situation? The money must be paid back to the Adam, right? Atomicity gives you guarantee that these two processes will work together like a single process. If one of them fails, then all the process will be rolled back. SQL database systems support atomicity. I think you get the idea. So what is scaling? First, let's delete these stuffs. Guys, scaling is separated in 2 parts. First one is vertical scaling. And the second one is horizontal scaling. Basically, scaling is upgrading the capacity of a database to be able to store more data. In vertical scaling, we upgrade the database by increasing the features of server such as CPU, HDD or SSD, RAM. With this operation, our database can store more data. So, in horizontal scaling, we create a new database server instead of increasing its feature to store more data. When new data comes, it is distributed between these database servers. Let's make an example to make it clear. I'm gonna draw a box. And this will be our database server. And this is the data that comes from outside. When this data comes into the server, it will be stored into database. Another data came, another, again and again. Now our database is full. We have no more space to store new data, right? So what can we do? If I increase the size of this box, then I will have more space to store new data, right? We call it as vertical scaling. Let's do that for horizontal scaling as well. I'm going to draw a box as a database server. When our database is full and there is no more space for new incoming data, we will create another box to store new data. If database 2 is full, then we can create another one to store new data. That is horizontal scaling. As you can see, there is a limit in vertical scaling, right? Because we can't increase the features of server forever. But horizontal scaling is different. It gives you freedom to increase the capacity. SQL database supports vertical scaling. NoSQL database supports both vertical and horizontal scaling. I think that is one of the most important features of NoSQL. So what about speed factor? Let's look at that. But first, delete all this and change the color. Guys, we can say that database speed is the only option to make our app fast. There are another options such as server location, features, internet bandwidth, etc. We must think about this as well. So, accept these options, what we want in our database to make it fast. Is it fast writing transaction, or fast reading, or fast development process, or fast scaling? Which one is prior for our app? We are going to understand the matter when we look at SQL and NoSQL. Let's begin with SQL database. SQL stands for Structured Query Language. It uses tables to store data, as you can see here in this example. At the top, we have students table with some students information. Below it, we have courses table with some courses info. At the bottom, there is scores table that shows the students' exams result. So in this table, the fields data type are fixed. What I mean? For example, here the ID field was defined as integer type, and the name field type is varchar. If I try to add an integer value such as 13 into name field, it will show an error that this field requires varchar type values. When we try to add a data into SQL database table, it makes a control to validate if the value type and the field type are the same. Because of that validation process, the SQL writing process is slower than NoSQL. So let's write down what we said. It uses table, store data. It uses fixed data type. Slower writing. So we said in SQL, the field type must be predefined, right? For that reason, we have to be very careful before design our database architecture, tables, etc. Because if you do not design a good database architecture, you are going to have some difficult times when you try to change the architecture. We can see that in SQL database, the development process is slower than NoSQL. Let's write it down. Alright guys, the one of more important feature of SQL is it uses relationship between tables. How? Here we have three tables, right? The ID field of student table has relationship with students.id field of scores table. And the ID field of courses table has relationship with the course.id of scores table as well. When you make relationship between tables like that and normalize the tables, it prevents the data duplication. So let's write prevent data duplication. Alright, in a SQL database table, the data is read row by row, and each row is read column by column. We can also say field by field. Tables can be merged by join command, and we can make complex queries. SQL is faster than NoSQL in making complex query for reading data. But don't forget that merging table with join command is expensive for performance. SQL uses indexing method to increase reading performance in database, and its indexing method is better than NoSQL indexing. SQL database supports atomicity. So if the data consistency is very important in your app, you can use SQL database. It supports vertical scaling. For that reason, there is a data limit in SQL database. I think you already know why. So we can show MySQL, PostgreSQL, Oracle as SQL database examples. Okay, when can we use SQL database? If you don't change the database architecture too often in your app, if you need limited database storage, if data consistency is important in your app, if you make complex queries in your app, then you can use SQL. So let's look at NoSQL. NoSQL known as not only SQL or non-SQL. Remember, in SQL, we store data in tables, right? But in NoSQL, we have different storing methods, such as document, key pair, graph, widecolumn. So here we have an example of document-based data, and as you can see, we are using JSON format to store data. Let's look at that. Remember, in SQL, when we create a name field with a data type, it would be fixed data type, and whenever we add a value into that name field, it must be the same data type, right? Here in this documents, we add string value to this name field, but we can also add another value into same field. we can add double value or integer value or string value, etc. Of course, we must be careful when we try to read this field because of data type flexibility. We don't want to read string data for our integer variable, right? Okay, let's write down no fixed data type. So another good thing about NoSQL, for example, I can add a new field into this row, let's say city and Konya. It doesn't matter if the other rows have this field or not. It provides flexibility. In SQL, we read the table row by row and in each row, field by field, right? In NoSQL, we read the whole row, even if you need only one field. Of course, it has its own advantages and disadvantages. For example, it is good if we need all the field, but if we need only one field in this row, we still have to read whole row. There is no need to merging some data group because we already have all the field in one row. So no need for join command. It is pretty fast for simple queries, but for complex queries, it is slower than SQL. So because we don't have to predefine any data field like SQL does, the writing transaction is faster than SQL. There is no need for field type validation before adding data into NoSQL. Well, there is no normalization in NoSQL, and we keep the fields in the same row. For this reason, there is too much data duplication in NoSQL. You can see in this document, in the code section, we have more than one math and science, right? We have said that there is no need for a predefined field type or pre-built architecture. NoSQL provides flexibility, and that means the development process is faster than SQL. And the one of the most important features of NoSQL is it supports horizontal scaling. So I'm going to explain the simple logic of how SQL is able to scale horizontally. Here we have our scores data group, right? And in this group, we have a hidden field called hash value. We also have a function, let's say hash x. This function receives an ID value and returns back a hash value between 0 and 100. Let's say the hash value of first row is 10, the second row 20, 30, and 40. So let's put these each row into 4 different servers. Here is server 1, server 2, S3, and S4. Let's say server 1 receives a hash value between 0 and 10. Server 2 receives between 10 and 20. Server 3 between 20 and 30. Server 4 between 30 and 100. With that hash x function, when we give an ID value to that function, it returns a hash value of that specific ID, and we know which server has that data. It is pretty cool, right? Okay, NoSQL is separated in 4 groups. These are document-based, key pair, widecolumn, graph-based. Now we are gonna go into detail each of these. Alright, we've just explained a little bit about document-based database. So let's summarize. It uses JSON format. In SQL, we call the data groups as table. In document-based database, we call the data groups as collection. Here, this is a data group, in this case, collection. And the sensor data is the collection name. Each row of this collection is a document, so we call this as documents. Well, there is no relationship between collections. We have said there is no need for a predefined field in document-based database. As you can see here, in this collection, we have different data type in the data field. The first one is double, second one is integer, and the last one is string type. I want to add another document here. Let's say ID is 4 and sensor type is velocity. This time I am not going to use data field. Instead, I'm going to use velocity data. Let's say 230. I can add one more field in here. Let's add a date field. As you can see, I don't have to use same field for each document. You can change the field name or use more field. Of course, using different field name for each document is not a smart approach because it may be difficult when we try to read those different field name. Anyway, it provides flexibility. So let's write down no fixed data type. In document-based database, we read data document by document. It is fast for simple and single queries. The more complex query causes slower reading transaction. It is faster at writing transaction because there is no validation during adding the data. It is useful for real-time app, data analysis, IoT apps, so we can say MongoDB CouchDB, DocumentDB are the examples of document-based database. So let's look at key pair-based NoSQL database. This database has the simplest storing method because you add the value with its key name. For example, here the name field is the key and Vedat is the value of that key. On reading transactions, you just give the key name and you get its value. So the key must be unique. To make it clear, let's think about our phone contact list. We are adding contact with name and phone number, right? In this case, the name of the person is our key and the phone number is the value. When we want to call George, we are just getting its phone number by his name and calling it, right? So it also uses JSON format. There is also no query language for that kind of database. We don't need it. Another good thing about key pair-based is we can read and write data simultaneously. And I think the most important feature is we can use key pair-based NoSQL for caching as storing data on RAM memory. We can combine it with another database when we do caching. So let me explain. Let's say this is our main database that runs on SSD drive. And let's say PostgreSQL or MongoDB. And this is our RAM memory. Our caching database will run on RAM memory. Normally, when a user makes a request to the main database, it responds back, right? When we use caching, the user request and its response will be stored in key value format into the RAM memory. If the user makes the same request, then this time the caching database will respond much faster back to the user. So the purpose of the caching is making faster reads and avoiding disturbing the main database. Don't forget that the data on RAM is temporary. Once you shut down the device, it will be deleted. So do some store on the main hard drive if you want those data later for future use. So what is the use case of this? If your app have a set of data that the client often use, you can use this kind of database. Session-based app is a good use case of key pair-based NoSQL. We can also use this kind of database in e-commerce app in the shopping cart section. Think about thousands of users adding, deleting, updating some product from shopping cart. It is a good use case too. Redis, Memcached, Amazon DynamoDB are key value pair-based NoSQL database example. So let's look at the widecolumn based database. Alright guys, before explaining the widecolumn based NoSQL, let me tell you about two storing methods to make it clear. The first one is row-based storing, and the other one is column-based or columnar storing. Cool. Now, as you can see guys, here we have some tables with some data. As we know, when we add data to a database, it is actually stored in blobs on hard drive. So at the top, we have a users table with some user information in it. At the bottom left, we save that users table with row-based format into the blobs. At the bottom right, we have stored the data with column-based format into some blobs. So what is row-based format? In this format, we get each line, each row of the user table and store it into the blob. So the data is stored row by row. Well, in row-based, we read the data from blobs, row by row. Each time we read the whole row, let's say we want to get the information of the user named Walter, first we read the first row of blob 1 and check each field if Walter is here. No. Then read the second row and check. No. And read the first row of blob 2. Boom, we found it. Well, as you may have noticed, in row-based, first we get the row, then we check each field of that row if our target is here. So let's talk about the pros and cons of this. If we read all the information of a user, I mean like select star query, it is pretty good to use this storing because we already read the whole row. But let's think about if we want to get the average of user's age. This is bad because we must read every row to get each age, right? Of course, it is not a big deal for the small size of data. But think about millions of data. That will be fun, right? So another good thing about row-based is we can delete or update data easily because all the information about the user is stored in one row, right? For example, if I want to change the Walter's surname from white to black, when I read the first row of blob 2, then I can edit the surname field. So what about adding a new field? Let's say we want to add a new field called salary. If I want to add a value into the salary field for a specific user, let's say for Vedat, I also should add a default value for the other users as well. Even if the other users have null value, they will still occupy space in the blobs. So that is row-based. Let's look at column-based. Remember, in row-based, we store data line by line. In column-based, we store data vertically, column by column, into blobs with its row ID. I mean, we will store all ID fields with its row ID into one blob, all the name fields into another blob, surname to another blob, and so on. So in the first blob, we store the all users ID value with the row ID. In the second blob, we store the name. On the third blob, surname. And in the last blob, we have age. It is weird, right? But it also has pros and cons. If I want to get all the information about Vedat, then I have to read all the blobs, right? It is not good if you have lots of fields. Of course, there might be different technologies to increase the performance for all the things that I told you. Here, I'm just explaining the basics of this logically. Anyway, if I want to get the average of all the users' ages, then I can go and read the blob 4. Because I already know where the age field is stored, right? I need to read only one blob. It is pretty fast to do some operations on a single field. Reading all the information of a user might be expensive if there are too many fields. Because we have to read all the blobs, deleting and updating data is a little bit of a challenge. For example, if I want to delete George's information, then I need to read all the blobs to find George's info. It is good if you want to add a new field, let's say salary field for a specific user. We only need another blob for storing salary. Let's add a salary's value for Vedat, and we don't have to add default salary value for the other users. This prevents storing redundant data. Alright, with that being said, what is wide column based? Wide column based is actually a type of column based storing. Remember, in column based storing, we store each set of fields in a blob. In wide column based, we can store more than one field in a blob. So what is that? Let's look at that. Here in blob 1, we have stored ID and name fields together. In blob 2, we have age and surname field. It is very useful if your app has fields that frequently used. We can store the frequently used data in the same blob. We can use this kind of database in data logging or IoT-based apps or data monitoring or in real-time data analysis, because in data analysis, we usually use few fields to work on. Cool. Apache Cassandra or HBase or Google Bigtable are the wide column based databases. Alright, let's look at the last one, the graph database. First and foremost, guys, remember the SQL database. It has a relationship between tables, right? And with that feature, SQL tables could be merged with join command. It was an expensive process, but it provides to make complex queries, right? Graph-based NoSQL database has been developed as an alternative to relational databases. As you may understand from its name, graph-based database stores data in graph format. This database uses relation between data. Each data row is called as node, and each data group is called as label. So we call all the field of a node as property. Nodes have relations with each other. We call these relations as H. Graph-based database has its own query languages, such as Cypher, Gremlin, GQL. If your app has too many relations between data, such as social media apps, then it is useful to use a graph-based database. So here we have a very simple example of a social media app user's relationship. Each circle is a node. It represents users. The user's text here at the top is our label, and each field of nodes are a property. You can see there are arrows that comes in and out from nodes. These are the relations, in this case, ages. Cool. In this example, we have 6 users, each stored in a single node, and each user has name, surname, and age properties. The users also follow each other. For example, let's say I want to find who is following Vedat. To do this, we are going to look at the arrows that comes into Vedat's node. 1, 2, and 3. So there are 3 users that follow Vedat. These are Adam Milton, Simon Storbolg, and Isaac Newton. So how many users are there that Vedat following? To find that, we can look at the arrow that comes out from Vedat's node. There's only one, Solomon Kane. Let's say, show me the users that follow Vedat and Isaac at the same time. There's only one, Simon Storbolg. As you can see, guys, it is pretty easy to make complex queries in graph-based databases. Neo4j, ArangoDB, dgraph are the graph-based database. Okay, that's it for this video, guys. I hope now you have got an idea about SQL and NoSQL databases. Just stay tuned and see you in the next video.